Now that we've done that and we got this stuff all down, let's go ahead and apply what we've learned to some equations. So this is going to be our first one. And I'm just going to go ahead and jot down the stuff we have to find. We have to find our vertex. We have to find our axis of symmetry. Pretty much what is the line that cuts our parabola down the middle? What's the direction? The direction of opening. I'm just going to put opening. Do we have a minimum and maximum? And we need to identify where. I want to do the y-intercept. And then I also want to do the discriminant. Okay. Copy that because we're going to need that in a minute. All right. So step one. So here's our equation. And that's our equation. We have to identify our A, B, and C. A is x, sorry, not x squared. When there's no number in front of the x squared, that is a 1. B equals -2. And C equals -4. So we have to find our vertex. And in order to find the vertex, we got to use the formula -b over 2a. And go ahead and write the negative and the 2 down. And then we'll fill in b. Because I don't want you to think that this negative right there is the 1. So, and then my a was 1. So all I did was remove the b, and I removed the a, and I filled them in, okay? Negative, -2, and that's the same thing as saying +2. And 2 times 1 is 2, and then 2 divided by 2 is 1. This happens to be the x-coordinate of the vertex. So I can go ahead and jot that down right there. And then step 3 said to plug this back into the original equation and see what we get for y. So we had y equals 1 squared minus 2 times 1 minus 4 equals 1 squared is 1 minus 2 minus 4. 1 minus 2 is -1. Minus 4 is -5. And so our y is -5. So in case you don't remember, this number right here came from solving this. And then this 5 right here came from plugging it back in. And then we got that. Perfect. Now that we have this, we can fill out just about everything else on this table. Where's our axis of symmetry? It's actually right here. X equals 1. And because this is a positive, that means it's going to open up. And because it opens up, that by default means I have a minimum. But where is my minimum? My minimum is right here. Y equals -5. And where's my y-intercept? Up -4. 0, -4. And the discriminant, we'll get to that in a second. Actually, let's go ahead and do that now. Our discriminant, we have to do b squared minus 4 times a times c. Well, our b was -2 squared minus 4. And then what's my a? My a was 1. And then my c was -4. Negative 2 times negative 2 is positive 4. Minus 4 times 1 is 4 times negative 4 is negative 16. And when you have these two next to each other, that ends up becoming a positive 20. Because our discriminant is positive 20, remember, anytime it's a positive discriminant, let's do a quick peek. That means it should cross our x-axis twice. So let's graph it and see what it looks like. Okay? Now, this is where I'm going to show you the patterns. And I'm also going to show you the table. So hopefully you have this part written down because I'm going to erase this up here because I'm going to need this space. I'm going to show you the pattern first. Then I'm going to show you the table in case the pattern is confusing to you, okay? All right. So my vertex is at 1, negative 5. 1, negative 5. And our pattern when our a equals 1 is 1, 3, 5. So I'm always going to go over 1, but I'm going to go over 1, up 1, over 1, up 3, over 1, up 5. Now I'm going to do the same thing, but to the left. Over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5. And then I'm going to graph, and remember, I just use those to count. Those don't belong on there. I'm going to graph this. Perfect. Oh, my handwriting is so great. All right. So, and if you notice that our y-intercept is this negative 4. Sorry, that negative 5 right there, which we found was down this way. All right. If you notice, I was able to graph that without the table, but I'm going to show you how to use the table. And our vertex is at 1, 1, negative 5. And I like to use the numbers just below 1 and just above 1. Okay? So we're going to plug all of those numbers into the formula. So I got to do negative 1 squared minus 2 times negative 1 minus 4. Negative 1 squared is positive 1. Negative 2 times negative 1 is positive 2 minus 4. And then I got 3 minus 4 is negative 1. If I go graph that right now, negative 1, that's that point right there. Okay, if I plug in 0, so I'm going to do 0 right here. 0 squared minus 2 times 0 minus 4. 0 squared is 0. Negative 2 times 0 is 0 minus 4. 0 minus 0 minus 4 is negative 4. And that happens to be this point right here. And then if I go on the other side, let's do this one in red. And if you're wondering what I'm doing, I'm just plugging all of our x's into this right here. Now, if I plug in 2 into that, 2 squared minus 2 times 2 minus 4. 2 squared is 4. Minus 2 times 2 is 4. Minus 4. Well, 4 minus 4 is 0. 0 minus 4 is negative 4. So 2, negative 4, it happens to be that one. And then finally, let's do this one in black. I'm going to use a 3. 3 squared minus 2 times 3 minus 4. Well, 3 squared is 9. Minus 2 times 3 is 6 minus 4. Well, 9 minus 6 is 3. 3 minus 4 is negative 1. And that's 3, negative 1. That's this point. And if you notice, all the points are on our graph without having to do the table. And I also want to point out that these will mirror these if you do them correctly after you've labeled your vertex. Okay? So that's how this works with the table. This is the only question I'll do with the table. The rest of them, I'm going to do with the patterns. All right? So we're going to keep going. All right. So, again, we need to figure out all this stuff based on this graph. And this one has some slight changes to it. It's not exactly the same as the last one. Step 1, we need to identify our A, B, and C. So our A, negative 1. B, negative 2. C, negative 2. Step 2, find the x-coordinate of the vertex using the negative b over 2a. So I'm going to go ahead and just put my negative and my 2. And then I'm going to go ahead and write my b in. I'm going to go ahead and write my a in. Okay? Now, a negative, negative 2 is going to be a positive 2. And then 2 times negative 1 is negative 2. 2 divided by negative 2 is negative 1. So the first part of my vertex is negative 1. Now I got to plug that negative 1 back into the original and see what the y coordinate is going to be. So y equals negative, I'm going to write it out real quick so you can see something, 2x minus 2. What I'm going to do is I'm just going to erase the x's. And I'm going to replace them with the negative 1 that we just found. Now, I did that because I don't want there's a mistake. A lot of students will think, okay, this negative next to this negative 1, let's go and make that positive. Don't do that right now. You have to take care of this first, then attach that at the end. So negative 1 squared is positive 1, but because there's a negative on the outside, that makes it negative 1 again. I'll say it again. We have to square it first because remember the order of operations, the second one or second letter's exponents, we have to square it first and then attach the negative on the outside. And then I got negative 2 times the negative 1 is a positive 2. And if I look right here, positive 2 minus 2 is 0. That goes away. So my y coordinate is negative 1. Oh, now that I have my vertex, I can label almost everything else except for my discriminant. My vertex, my axis of symmetry is at x equals negative 1 because it comes from right there. And because my A is negative this time, this is going to be an open down. So it's going to look something like this. And because it opens down, that means I have a maximum. Where's my maximum going to come from? Right here. Y equals negative 1. Your y-intercept is just whatever's at the very end. That's going to be 0, negative 2. And then my discriminant, I'm going to use it really quick just to tell me how many solutions I should have on this one. B squared minus 4ac. My b is negative 2 minus 4 times negative 2 times c is going to be negative 2 again. Sorry, A is not negative 2. A is negative 1. That does not go there. That does. Okay, there we go. 4AC. All right. Negative 2 squared is a positive 4 minus 4 times negative 1 is negative 4. Negative 4 times negative 2 is negative 8. Sorry, negative 4 times negative 2 is a positive 8. And then when we subtract these, negative 4, 4 minus 8, I keep messing up. 4 minus 8 is negative 4. Again, just to make sure you guys aren't confused by my slip-ups, 4 times negative 1 is negative 4. That negative 4 times a negative 2, negative 4 times negative 2 is this positive 8. And then this minus sign was just the one that was from right there. Okay? So, oh, wait a minute. This ends up being a negative. When our discriminant is negative, that means this should be no solutions. And that means when we graph it, it should not touch the x-axis. All right, so let's go ahead and put our vertex in, -1, -1. And our pattern is 1, 3, 5. Although it's negative, we just go down this time. So over 1, down 1, over 1, down 3. Over 1, down 1, over 1, down 1, 2, 3. You don't have to do the 5. And there's our graph. And you see that it doesn't touch the x-axis. And our y-intercept that we figured out earlier, this y-intercept right here is this one right there. Okay, moving on. Oh, we have a number in the front for A now. That's going to change something slightly. All right, but we still need the same stuff. All right, so we still got to find our vertex, axis of symmetry, all that stuff. And the process is still the same. A is now -2. B is now positive 12. And C is -18. Okay, so now what we're going to do is I got to do my negative B over 2A. I'm going to put my negative in my 2. My B is 12. And my A is -2. So this ends up becoming -12 over -4. And that makes that a positive 3. That's the x-coordinate of my vertex. Now I got to plug that 3 back into the equation. To get the x-coordinate out. Well, 3 squared is 9 times -2 is -18. 12 times 3 is 36 minus 18. This ends up becoming -18 plus 36 is 18 minus 18. And our y-coordinate happens to be 0. Now that we have that, we can go ahead and figure out most of the other stuff. Our axis of symmetry is right here. X equals 3. Our opening, because our A is negative, is going to open down. And anytime it opens down, that means we automatically have a maximum. But where is the maximum located? At y equals 0. My y-intercept is going to be at 0, -18. Although you may not see it on the graph, that's where it'll cross. And the discriminant, I got to do b squared minus 4ac. B squared, so my b, again, was 12. Minus 4 times the A is negative 2, and times C is negative 18. And my handy dandy calculator here, although I don't need it for 12 squared. 12 squared happens to be 144 minus, now I'm going to do 4 times negative 2 times negative 18, and that's going to be positive 144. Uh-oh. What does that mean? 144 minus 144? That's a 0. So if it was positive, it's 2 solutions. If it's negative, no solutions. When it's 0, it's a 1 solution. And a 1 solution means it's a bounce. And so what that looks like on a graph, let's go ahead and graph it. We have to put a dot on 3, 0. That's this one. And because our A is 2, instead of going 1, 3, 5, this is a 2, 6, 10. So over 1, down 2. Over 1, down 6. Over 1, down 2. Over 1, down 6. And this is my graph. If you want to verify it using a table, go for it, okay? We got 2 more, I think. All right, here's one with the half in it. Perfect. Because I know y'all really dislike fractions, but it's okay. So we still got to find the same stuff. Vertex. I still got to identify my A, B, and C. My A is 1/2, positive 1/2. B equals 2. C equals negative 1. Oh, by the way, if you got to this point in the video, I would probably go down and check this question out because it looks pretty crazy, but it's not that bad. But yeah, back to this. All right, so we got to find the vertex, negative over 2. And then I got to put my B there. And my A is 1/2. So this ends up becoming negative 2. And then 2 times 1/2, that's the same thing as doing this. So we're going to do 2 times 1 is 2, but divided by 2 is 1. And then negative 2 divided by 1 is negative 2. That's the x coordinate of the vertex. Now I'm going to take that negative 2. I'm going to plug it back into the formula. -2, -1. And anytime you're multiplying a fraction, you can essentially say the word of, okay? So, and what I mean by that is this. We're going to go ahead and multiply this right here. -2 squared, that's positive 4. Half times a positive 4 is exactly like saying, what is half of 4? And that answer is 2. Or you could have done 4 times 1/2. Then multiply straight across. 4 times 1 is 4. 1 times 2 is 2. 4 divided by 2 is 2. You could have done this work off to the side. But if you can process this mentally, it'll be great. So again, half of 4 is 2. And then positive top, oops. And then I had a positive 2. Yeah, still. Positive 2 times a negative 2, negative 4, minus 1. 2 minus 4 is negative 2. Negative 2 minus 1 is negative 3. With that being said, I can find my axis of symmetry and all that good stuff. My axis of symmetry is at x equals negative 2. That came from there. And this is a positive A. So this means it's going to open up, which means I have a minimum. But where's my minimum located? I get it from right here. My y-intercept should be at -1 if I do it right. And my discriminant, b squared minus 4ac. And before I do the discriminant, I'm actually going to graph it, and let's see what it should say. Let's see what it should say. Okay. B squared. Sorry, I'm not doing that. Graphing. Vertex, -2, -3. And because my graph is a half, this is the one that's kind of tricky. I'm going to go over 1 up a half. Over 1 up a half. Okay? Now I got to go over 1 up 1.5 from there. Why? Because remember, if our A was 1, 1, 3, 5. If our A is 1/2, we got to cut all these in half. Half of 1 is 3. Half of 3 is 1.5. Half of 5 is 2.5. So I gotta go over 1, up 1.5. Well, here's the half, and here's the whole one. That's a half. That's a whole one, and that's like a half. So that's 1.5. Okay. That's not what I wanted to do. I don't know why it drew an arrow. I'll do it like this. All right. And then the same thing will happen on the other side right here. Then you graph it. And yeah, that's perfect. And you notice it crossed at the -1 like we predicted it would from right here. And we're not going to find the discriminant of this one. But when we do it, we'll find out our number ends up being positive. And then that's how you know there should be 2. Now on this one, we're not going to be graphing that. I just want you to find all the stuff. And you guys hate fractions, which is exactly why we're doing this one. You hate fractions. All right. So our A is 1/3. Our B, -8/3. And our C, 13/3. Yee. All right. So I got to put my negative and my 2. My B, because this is negative b over 2a, my B is -8/3. And my and my A is 1/3. Negative times a negative is a positive. So 8/3 divided by 2 times 1 is 2. Divided by 3 is still 2/3. And back in the day, like in elementary school, you learned this thing called keep, change, flip. So you keep the top, change this to a multiplication, flip this. This flip right here came from flipping that. And then 8 times 3 is 24. 3 times 2 is 6. 24 divided by 6 is 4. So this all equals 4. That is the x-coordinate of the vertex. Now I got to plug that 4 back into the original equations. So y equals 1/3 times 4 squared minus 8/3 times 4 plus 13/3. Now, because you see all this, don't panic and freak out, especially because you have all common denominators. That makes this nice. So 4 squared is 16. So this becomes 1/3 times 16 here. That's like this first thing right there. And then we're going to do minus 8 times 4 is 32 over 3 plus 13 over 3. Well, 1 times 16 is 16 over 3 minus 32 over 3 plus 13 over 3. And then remember when you learned this in elementary, when you have a common denominator, you keep it the same. We got to just do 16 minus 32 plus 13, and that happens to give me -3. -3 divided by +3 is a -1. That is the y coordinate of our vertex. And from there, we don't need this one. And from there, we can find our axis of symmetry. Axis of symmetry is going to be at x equals 4. We have an opening. The opening is going to be up because A is positive. And because it opens up, that means I have a minimum. But where is my minimum at? Y equals -1. And my y-intercept is going to be at 0, comma, what did they say C was? 13 over 3. Okay? That is graphing quadratics in a nutshell. That is a quick crash course. If you need to repeat any part of this video, go ahead and do that. If not, if you have any more questions, you can see me in class. Have a good day.